Hello students, welcome back to my channel. And now I'm going to solve some problems from CSIR-NET exam. So this problem came in June 2022, and here they have given you the Hamiltonian, and they're asking what is the energy value for this given eigenstate. So this is the eigenstate for a given Hamiltonian, and we need to calculate the energy for this eigenstate. So let us calculate this value. So we have be given Hamiltonian. So we have a Hamiltonian, say H, and we have a state phi. I want to find the eigenvalues. So you have a N, you have a say E, and this is given. You have a one state and then you have E n plus 1, and then you have a N, and then your third term E ket N and bro n plus 1, and say this is in whole, say this is the whole bracket. So you have a E, say N, and then you have say a, this is, so this is given. Now I want to find the phi. Phi is also given. Phi is what? Phi is summation, and I'm writing it as m e power m phi because there's two summations, so I'm writing as m. So let us operate now this on phi. So you will become two summation, one is n, one is n, this is m. Now when this m operates on this delta nm, what will happen? This become e and this become nm. You have a e power m phi, and then you have a delta nm, and m will be delta nm when first term. Now you go to second term, you have a e n plus 1. Again, you have a e power iota m phi delta nm. And similarly, you go to the third term, you have a e. Now you have here, say, this is a bra here, n plus 1. So again, if you operate here, so you will have a delta n plus 1, delta n plus 1 m e power iota m phi, because nm is, you have a n plus 1, m will be delta n plus 1 m. Now let us simplify it further. So this have a value only n equal to m. So I can solve, I'm putting in this is n. So this become e n, and this become e power n phi. Similarly here you become e n plus 1 iota n phi. And here, if you go here, this term, here you have a e n, and now this become m equal to n plus 1. So this become e power iota n plus 1 phi. Now let us simplify further. So now you have, say, summation n. This term have, you have a en e power iota n phi as it is. Here you have n plus 1. Here you have a n. I want this should be converted into the state n. So I can change the indices, n plus 1, I can put m. So this will become m minus 1, and then again I can bring it to the form of m. So I am reducing it. So this term will become e factorial n, and now this will become n minus 1. I am making this is the n. I can do new substitution, and I am making it a e power iota n minus 1 phi. and here you have already E n, and then you have a e power iota n plus 1 phi. Now just one more step. I can take, I can write this state as, I can take n phi common. So I can take this common. So this will give me 1 plus e, and I'm taking common. So you have this one, say E is here, so E is here will be E. And phi I'm taking common E, and here you will get e power minus iota phi. Similarly, here you will be remaining E plus iota phi, and I'm taking common e power iota and phi, and then you have this one. So this is my state. Now this term is independent of n, so this will become E plus E common, this become e power iota phi plus e power minus iota phi, and then your summation n, you have a e power iota and phi n, which is my phi, and now this will become e plus e 2e. This I can write as a cos phi e, and this is my phi, this is my phi, e phi and phi. So now the eigenvalue become e plus 2e cos phi. That is, if I see the option, this option C is the correct answer for this question. Hope you understand the solution. Thank you very much.